My name is Marion Sudvarg, and I am presenting a fast GRB source localization pipeline for the Advanced Particle-astrophysics Telescope. APT is a space-based observatory to survey the entire sky for gamma-ray sources. When a GRB is detected, it must rapidly communicate with narrowband instruments for follow-up observations. To achieve this, it will fly with low-powered computing hardware, for which we have developed an efficient software pipeline to localize GRBs in real time. A GRB in the Compton regime is constrained to a circle defined by the first two interactions, with an opening angle determined by the Compton law. For each incident photon, the APT detector reports a sequence of interaction coordinates and energies, but the ordering is unknown. Our software picks the ordering that minimizes a chi-squared statistic representing the disagreement between the measured angle of each scattering and that implied by the Compton law. Instead of considering all permutations independently, we perform a tree traversal where a node at depth k corresponds to a choice of the first k interactions in order. Thus, the computation of the chi-squared contribution for a common initial subsequence need only happen once. Additionally, several heuristics allow us to prune the tree as it is traversed. Once we have inferred an ordering, we propagate an annulus with a width representing the uncertainty. For multiple such annuli, we estimate the true source direction. First, we sample multiple annuli, estimate a likely source direction contained within each one, then average these source estimates to compute a rough approximation of the source direction. Second, we use an iterative least squares refinement of this initial approximation, identifying and using only those photons most likely to have been correctly reconstructed to derive a final estimate. We tested our pipeline on a Raspberry Pi 3B+, representative of what might actually fly on APT. For low fluence events, we achieved reasonable accuracy, localizing within 2.5 degrees 68% of the time. For high fluence events, we achieved sub-degree localization 95% of the time, while delivering results within 200 milliseconds for a 1-second GRB, demonstrating successful real-time computation.